Welcome to part 3 of naming aldehydes. So let's begin with this example. As I promised last week, we're going to have two aldehyde functional groups. So how do we name this one? First, you want to count the longest chain. So we have 1, 2, 3. This would be associated with propane. However, we have two aldehyde groups, so this is going to be called a diol. Propane diol is going to be the name of this structure. Now let's get a little crazy with this. So the reason I've gone all out on this one is to teach you the names of all these substituents. Move this up so it's easier to write on the bottom. So first thing, obviously, count all the carbons. But we have two options. We can either count from right to left or left to right. Whichever direction we count on, the number of the substituents are not going to change. However, if we count from right to left, we're going to give priority to the alcohol group. The alcohol group is called hydroxy. The left one, bromine, is called bromo. Now notice that B comes before H in the alphabet, so therefore we're going to start counting left to right to give this one priority. And we can do this because whether we count right to left or left to right, it's not going to make a difference in the sense that every single carbon other than 1 and 7 has a substituent on it. Now the names of the other substituents, this one's going to be amino. NH2 is always amino as a substituent. And then this right here is an ether with 2 carbons. An ether with 2 carbons is called ethoxy. If it was 1 carbon, it would be methoxy. So that's the names of all of our substituents. Now let's write the parent name. We're going to have 7 carbons, so that's associated with heptane, and we have 2 aldehyde groups like this, so this is going to be heptane diol. Now to start naming these substituents, we want to start with the ones that come first in the alphabet. So amino comes first and it's on position 4, so it's going to be 4 amino. Next we have bromo on position 2, so it's going to be 2 bromo. And I forgot to name this one. This is a propyl group. Then we have, I believe we have ethoxy on position 5. So 5 ethoxy. And then we have, does P come first or H? I think P, or actually H. Yeah. The hydroxy is going to come first. So it's called 6-hydroxy because it's on carbon 6. And we run out of space. Of course we did. And then we have the propyl on carbon 3. That's going to come last. So it's a pretty tough example, but teaches you all the names of these substituents. And I hope I didn't make a mistake there, because I realized that on my paper I did make a mistake. So let's talk about this compound. You can see that this one's a lot simpler compared to the last one. We're going to have 5 carbons, which would be pentane, and due to our 2 aldehydes, we're going to call it pentane diol. Substituent on carbon 2, Again, if you have a benzene ring with no extra carbons, this is called phenyl. And it's on position 2, so it's going to be called 2-phenyl, and then you're going to have the parent chain name pentane diol. So now for our last aldehyde, let's say that we had a cyclohexane ring, and then we had an aldehyde attached to it, and let's say we had another aldehyde. Now CHO is the same thing as this. So in this case we have two aldehydes both attached to a ring. They're both on position 1, so we're going to put 1, 1, and this is cyclohexane because there's 6 carbons, so hexane, cyclo because it's a ring, and then diol because there are 2 aldehyde functional groups on it. So that's it for this video. Thank you for watching.